Hello, I'm Bonnie Holland from ArcLight Technologies. This video is part of a series of videos based on Mathew North's book, Data Mining for the Masses, published by Global Text Press, copyright 2012, and available for $39 from Amazon.com. This video is made with permission from Mathew North. RapidMiner is a text and data mining tool that regularly appears at the tops of surveys as a leading open source tool for these kinds of applications. It's available on the website at rapid-i.com. I have brief 5 to 6 minute videos on how to install RapidMiner, run the online tutorials, and add extensions on my YouTube channel. Search YouTube for ARCLIGHT, ArcLight Technologies, and you should see the videos here. There's 1, 2, and 3. Each chapter in Data Mining for the Masses shows an example data mining process on a sample set. This is for Chapter 4, Correlation. In correlation, you want to find out if any variables change in conjunction with one another. Does one increase as the other increases, and if so, we would say that they are positively correlated, and ask what is the proportional change between them. Alternately, if one variable decreases as another increases, then we say that they are negatively correlated, and we ask what that proportion is. So before you run any of these, you need to download the data sets, and they're on the web at www.sites.google.com/site/data-mining-for-the-masses, insert /this. Here you can see the site, and you can see the Chapter 3 data series, Chapter 4 data series, all the rest of these. So I already went ahead and clicked on this link, which is the download link, to download this, and I've stored it on my machine in a directory where I can find it. So going into RapidMiner, the first thing I want to do is create a new local repository, and I'm going to call it DMFTM, Data Mining for the Masses, for this book, and I'm going to tell it where I want the directory to go. I have a directory called Data Mining for the Masses that I want to store all this work at. So I say finish, and you can see that the new directory, the new repository has been created here. So then the next thing I need to do is import the CSV file. Now, if you don't know what a CSV file is, it is a text file where there are fields and records, and they're delineated by commas. So there's a comma between each field and a record. You can look at this file in Excel, and here I have opened Chapter 4 data set CSV in Excel, and you can see that when I import this file and tell Excel it's a CSV comma separated file, then I get all of the fields in each record. So for this record, here's the insulation amount, here's the temperature, here's the heating oil that was used, here's the number of occupants in a home, here's the average age of the people in the home, and here's the home size. So this is the input information that we have on this record. And you can see all of the rest of the records as we scroll down here. If we scroll down in this spreadsheet, down to the bottom, you can see that there are 1,219 rows. The top row, you'll remember, is the name for each of the fields in the record. So there's 1219 minus 1, or 1,218 records in this file. So going back to RapidMiner, I'm going to import that file. So I have to say import a comma-separated version file. And I need to tell it where to look on my machine. I happen to have stored it here, and I find the data set. This window I need to resize so you can see it better because it's off the screen. Here's the data import wizard back. I've clicked on Chapter 04 dataset, and then I say next to import it. Now this is interesting. Even though it's a CSV file, and everybody knows that means comma separated, RapidMiner needs to be reminded that the separation between the fields is the comma. So do you see what happened there? The default is semicolon. It's looking for semicolons. There are none in there. So it doesn't know how to separate out these fields for each record. As soon as I click on comma, boom, you can see that it's got attribute 1, attribute 2, attribute 3. it still doesn't know that these are the names of those attributes. We'll do that next. So I'm going to click on Next. And this is where I say this first row of data is special. It is the name. This is where the name fields are situated. So once I do that and click on Next, you see that it has determined that each of these have various values, either integer or real values. Real values have a decimal component behind them. So it knows the name of them, it knows that they're each attributes, and it knows that most of them are integer and one of them is a real. So at this point, it has previewed the first 100 rows, but it hasn't really imported it yet, so you have to say Next and tell it where you want it to go. I want it to go in this repository, and I'm going to call this Chapter 04 Data. And then I'm going to say Finish. Then if I open up this repository, I see that it's in here. Now I've already got a Chapter 4 run because I was testing this out ahead of time. But typically that wouldn't be in there, so I'm going to just delete it now so it doesn't confuse things. So now, to start the example from Chapter 4, I can drag this data into my workspace here in the design perspective of RapidMiner. And you see errors come up down here, but they're not terrible errors. They're just sort of yellow yield signs. They're not a big problem. And then this red means this hasn't been run yet. So I can drag this retrieve in and run it. And it asks me, do I want to save the process before I start? This is where I'm going to name it. I'm going to name it Chapter 4 Run. And I'll store it in this repository. So now I can see the data view, and this is a statistical analysis. You can notice, and you should check every time, that you have no missing data for every one of your attributes. That's good. It tells you the range of each of these attributes. So the insolation goes from a ranking of 2 to 10. The temperature outside goes from 38 degrees to 90 degrees. The heating oil consumption goes from 114 to 301. The number of occupants goes from 1 occupant to 10 occupants in a household. And then you can see that the average is over here, 3.113 is the average occupants. So this looks like it has loaded correctly. If you want to look at it from data perspective, you can click on this tab, and now you see row 1, 2, 3, just as you saw in the spreadsheet before, so you feel good that it's loaded in. For this example, going back to the design perspective, what we're going to do is an operator called correlation matrix. You can get there two different ways. You have to click on the operators tab over here, and then you have to go down to modeling, and then correlation, and I'm sorry I made this window so small, dependency, and then correlation matrix is under it. Alternatively, this is a box where you can type in the word correlation matrix and it should find it for you. Whatever you do, you just have to find this operator and then drag it on here. And I'm going to drag it. Do you notice how that line gets a little bit wider when I drag it there? When I do that, it will connect it in right behind the retrieve operator. So it'll connect them together. And you see that there's now the output from retrieve goes into the correlation matrix operator. Typically there are default settings on most of these operators, and they usually work fine for a first cut, so you don't have to worry about them. You can just sort of leave them the way they are. On this one though, I want to make sure and get the correlation matrix as an output. So I'm dragging that over here and connecting it to one of the receptors over here so that it will get caught. Now, if I run it, it'll ask me if I want to say yes, that's good. Now I get a correlation matrix, and it says we've looked at every one of these and we've seen how well they correlate. Now, not surprisingly, when you look at the correlation between any operator and itself, so here's insulation and insulation, here's temperature and temperature, here's heating oil and heating oil, here's number of occupants and number of occupants, here's average age and average age, here's home size and home size. This diagonal in this matrix is ones all the way because every operator correlates positively. That's a +1 correlation with itself. As insulation goes up, exactly the same amount. That's what this is saying. Okay, now let's look at the ones that are not ones. We have some, and notice that the higher the number, the higher the absolute value of the number, the darker blue it is. So these ones are the darkest blue in my matrix. Now let's look at the rest of the correlations. There's a relatively strong correlation between heating oil and insulation, 0.736, and it's positive. That means that they move up together and they move down together. And it appears both here in heating oil under the insulation column and in the insulation row under the heating oil column. So the same number appears both places. There's a relatively strong 0.794 negative correlation between temperature and insulation, and again it appears in both places. So when one goes up, the other one goes down. Let's look at the strongest correlation here. This is the 0.848 positive correlation that occurs between heating oil and the average age of the people in the home. So what this is saying is as the average age in the home rises, the average heating oil consumption rises. Now, we don't know if that is a cause, and we can't say that it certainly is, but you have to be careful about this. Look at another correlation. This is a negative correlation. As the temperature outside drops, the average age of the people in the home goes up. Well, that doesn't make any sense either. So one of the cautions that you always have to think about with this is never to confuse correlation, that is statistical correlation, and causation. I hope you've enjoyed this video on correlation, and I'll see you in other videos. Thanks for watching.